Hello friends, today I will be talking about type 1 and type 2 error. So this particular two concepts, type 1 and type 2 error, are quite important, quite relevant. It is very much popular idea or very much important concept for every researcher whenever they are conducting a hypothesis testing or whenever they are trying to interpret the result of a hypothesis. So let us try to understand what is type 1 and type 2 error. So what are type 1 and type 2 errors? So as I told that whenever we are going for hypothesis testing, so you have to use or you have to utilize the idea of type 1 and type 2 error. So whenever you are interpreting the result of hypothesis testing, if it is significant or not significant, you have to take care of type 1 and type 2 error. That means you have to take care that you are not committing type 1 or type 2 error. So before understanding type 1 and type 2 error, we should understand what is hypothesis testing, and then we can always understand type 1 and type 2 errors. So let us try to understand that how type 1 and type 2 error are important for any statistical analysis and for making any real world decision. So before so while performing statistical analysis, there is importance of understanding type 1 and type 2 error, so that our decision based on hypothesis testing can be actually error free. So let us try to understand. So whenever you are going for hypothesis testing, you suppose in a social science research or research in the field of education, we try to frame certain hypothesis. Basically we try to frame a null hypothesis that there is no significance difference, or we are saying that there is no significance relationships, or there is no significant correlation. So basically null hypotheses are framed whenever we are going for hypothesis testing. So as you can see here, the null hypothesis is where you are stating as there is no effect or there is no difference. Suppose there are two groups, suppose you are stating that there is no difference between the boys and girls in their achievement test score, or you are saying that there is no relationship between the height and the weight of secondary students. So this type of hypotheses are called as null hypothesis. Now there is also the other hypothesis which is called as alternative hypothesis. So when we are stating as there is a effect or there is a difference, when you are saying that the experimental group has performed better in comparison to the control group, then you are stating it in alternative form. Or you are saying that there is difference between the boys and girls in their achievement, then it is in alternative form. So whatever may be the situation, either you are making null hypothesis or you are making alternative hypothesis, either you are using a one tail test or you are using two tail test, you are going to take certain decision that are you convinced enough to accept the null hypothesis, or you are not convinced to accept the null hypothesis. Or you can say that either you successfully reject the null hypothesis or you fail to reject the null hypothesis. So this is the idea behind hypothesis testing. And you must have heard about significance level, which I have talked in the other video. The significance level is the chance of committing an error or a chance where you are going to reject a null hypothesis and you are committing an error. Suppose simple example is there. Suppose you have framed a null hypothesis that there is no difference between the boys and girls, and you collected the data from the sample, and then you got the you perform the t test, and your t test value is um, high enough, or when you are comparing it at 0.05 level, you comparing with the table value and you find that it is higher than the critical value or the table value, then you are rejecting the null hypothesis. That means you are saying that no, the difference is there. So alpha is the chance of committing the error of taking this decision. Suppose you are making alpha 5% or making keeping alpha 0.05, that means you have taken decision with only 5% error that there is significant difference between the boys and girls. That means by only 5% chance is there that you may not be true when you are rejecting that null hypothesis. So that is called alpha level or significance level. For understanding significance level, you can always watch my other video based on significance level. You can go through the video gallery of my channel, and you can see there video on significance level, confidence level, and confidence interval. So what you are going to do, you are framing a null hypothesis or alternative hypothesis, and when you are taking a decision, then how much certain you are about your decision, either to reject null hypothesis or to accept null hypothesis. So that is the overall planning of hypothesis testing. Now let us try to understand briefly about type 1 error. It is also called as false positive. Suppose you have framed that there is difference or there is an effect of the treatment variable. Suppose activity based method is working better in comparison to the traditional method of teaching. You are saying that your method is working, or you are saying that your medicine is working. Then how much is there that you are taking this decision by mistake? Means you are rejecting the null hypothesis. Null hypothesis is that there is no effect, there is no difference, your medicine is not working, or medicine is quite trivial. So that is your null hypothesis, but you are taking a decision that our medicine is working, or the group are different, there is difference between the boys and girls, or you are saying that the experimental group is performing better. That decision you are taking, and the possibility may be there that your decision is mistake, or decision is wrong. That means in reality there is no difference, but you took the decision that there is a difference or there is an effect. So this is called type 1 error or false positive. That means you say that you found something, but actually there was nothing, there was no difference, there was no effect, but you are saying that there is a difference. So that is called type 1 error. Now what is type 2 error? The other case may be that actually the effect is there, actually there is a difference, actually there is a correlation, but you fail to detect that difference, you fail to recognize that particular correlation. So that is called as type 2 error or false negative. You are saying that okay, that medicine is not working, or that drug is not working. You are saying that experimental treatment is not working. You are saying that the groups are not different. But if you are committing a mistake by taking this decision, then it is called as type 2 error. So type 1 error is also called as alpha error, and type 2 error is also called as beta error. So we will try to understand by taking some example. So again, let us try to understand. Type 1 error is called as false positive. That means you are saying that actually the drug is working, the experimental treatment is working, the group are different, the correlation is there, but actually in reality it may not be there. So if you are taking a decision that your groups are different, relationship is there, and that in reality in the population that difference is not there, so it is called as false positive. So example from education: concluding a new teaching method is effective when actually it is not. So that is called as type 1 error or alpha error. So a school Other example is there: a school falsely identifies a student as needing special education where they don't. So your null hypothesis is that there is no requirement of any special education, but you took the decision based on certain statistical test, t-test, ANOVA test, or whatever test you are applying, and you took your value you got higher than the table value, and then you are saying that the difference is there, or that special education is required, but actually in reality it may not be there. It may be due to various reasons. It may be due to your instrumental error, it may be due to your small sample size, whatever may be the reason, but you have taken a wrong decision that your system is working or there is a relationship, then it is called as type 1 error. The other error is type 2 error, or which is called as false null hypothesis. That means you should reject the null hypothesis. That means in reality this method is working, the correlation is there, the effect is there, but you fail to detect. Here also it may be due to sampling error, it may be due to instrumentation error, it may be due to any other random error or any other systematic error, but whatever may be the reason, but you took a wrong decision by saying that our null hypothesis is true, but actually it was false. So that type of error is called as type 2 error or beta error. So examples from education: concluding a new teaching method is ineffective, it is not working when it actually works, and you fail to identify that there is requirement of a special method of teaching for the special children, for a particular group of children, but you fail to identify. So that is called as beta error. So type 1 error is known as alpha error or false positive. Type 2 error is called as false negative or beta error. Now let us try to understand this particular thing by a very popular example. Anywhere in the books, in the literature, you will get this particular example. So suppose if you will understand this example, you will be able to understand entire fundamental of type 1 error and type 2 error. Now you all know that whenever a particular person is convicted or is indulged in a particular case, then you have to go for a court hearing, and then you are asked to put your evidences, and then the public prosecutor is there, and then the government prosecutor is there, and they try to produce their own evidences, and then they try to prove that if either the person is guilty or he is not guilty. So our null hypothesis in this case will be that the person is not guilty. That I think you can understand, that whenever a person is there who is a case is raised against him, then the court or the system says that he is not guilty. So that is our null hypothesis. So you have got your null hypothesis that the person is not guilty or he is innocent. So that is our null hypothesis, and you go for the case, and there suppose in reality, just try to understand this in green color, you can just deep green color, you can just try to see that in reality that is the actual condition, that that person is innocent. Now what happens, that the court takes a decision that he is a convict. It may be happening because what you can say, the advocate or that person is not able to produce evidences to prove himself innocent, and then the court takes a decision that he is convicted, but in reality he was innocent. So if you reject that null hypothesis that he is not guilty or he is innocent, and it is the real situation also, then you are committing a type 1 error. So innocent get punished. So this happens. Now it may be also there that in reality the person is innocent, and you also accuse that particular person. Accuse means you just try to say that he is not guilty, so conviction is not there, then that is a correct decision. So here no error is there. So in reality he was innocent, and the court also take the decision that he should be acquitted, so he should be let free. So this is a correct decision. Now the other case can also apply, that in reality the person is guilty. Okay, that means at 0 you have framed that he is innocent or non-guilty, but in reality he is guilty. He is a person who has committed the crime. Now if the court take a decision that he is convict, then of course he is the court is taking a correct decision. So in reality he is guilty, and the court also taking the decision that he is convict, so he is taking a correct decision. But it may also happen that the court fails to get a sufficient evidence in this case also to prove him particular that person guilty, and then the court will acquit or let the person move free, and in this case the court is committing a type 2 error. That means in reality the person was guilty, but he was let free. So this is called as type 2 error. So in this way you can understand that if an innocent person, in reality a person is innocent and the court says that he is guilty, then it is a type 1 error, and in reality if that person is guilty and court leaves him or leaves him free, or he can be free, then it is type 2 error. So this is the classical example to understand type 1 error and type 2 error. So you can also see that particular statement, null hypothesis is defendant is not guilty. So defendant, whoever that person is there, he is not guilty, and court also goes with this particular statement. So type 1 error is that innocent person is convicted, that person is convicted, then it is a type 1 error, and type 2 error is that that person may be guilty and he is left free, he is moving free, then it is a type 2 error. So in this way you can understand type 1 and type 2 error. So this type of mistakes we can make while doing a hypothesis testing in research in social sciences or in education. So now try to understand this type 1 error and type 2 error in terms of alpha and beta, which I already told you that it is also called as alpha error and beta error. So alpha error is probability of making type 1 error. So what is the chance, or what is the probability which is acceptacceptable of making type 1 error? So in social science research we give 5% or 0.05 level of probability of committing type 1 error. That means if you are saying that, or if you are rejecting the null hypothesis, then you should be 95% sure, or 5% chance you can take before taking a decision. So whenever you are checking the table value, you are referring the table value at 0.05 level. That means when you will be 95% sure that there is difference, then only you should reject null hypothesis. So alpha is level of or chance of committing type 1 error. So in that way also you can understand. So it is the risk of falsely concluding a new curriculum improves grades. So this is the risk of falsely concluding a new curriculum improves. Suppose you are saying that a new curriculum is there and you just try to make a null hypothesis that this curriculum or new curriculum is same as the old curriculum, then by conducting particular test or some attitude scale, you got the statistics, and then you try to compare that from the table value. You try to see that if the calculated value is high enough that you can take the decision that the new curriculum is working, then what is the how much risk you should be accepting. So 0.05 is in social sciences 5% is the risk which is acceptable. Now what is beta error? Now beta error is probability of making type 2 error. So whenever you are failing to detect the uh, effect, or failing to detect the correlation or relationship between the variables or between the two groups, then what will be the chance? Here also the chance should be 5%. That means by 5% only you should miss the chance of not able to detect the effect or detect the relationship. So that is called type 2 error. So it is the probability of making type 2 error. So every time whatever alpha, whatever beta is there, you should try to make the hypothesis testing, or there is a level of alpha and level of beta, try to keep it low, so that the errors will be low. That means whenever the effect will be there, what is our actual objective? The actual objective is there that whenever there is an effect, it should be detected, and whenever there is no effect or no relationship, then we should not reject the null hypothesis. So the first one is related with alpha, and the second one is related with beta. So it is also called as significance level, that you can always see from my other video, which is made on level of significance and confidence interval. So there also you can understand what is significance level, how alpha is related to type 1 error. So I already told that typically it is set at 5%, that there is only 5% risk of type 1 error. Now there is one term which is quite popular, you must have heard, power of a statistical test. So basically whenever you are conducting a test, suppose t test, f test, or any other statistical test, or a particular technique whatever you are using, or device whatever you are using, the power of that particular test and device should be that if there is a effect, there is a difference, there is a correlation in reality, then it should not be missed. That means you must not commit type 2 error. So 1 minus beta is that you are committing type 2 error. That means you are failing to detect the effect, failing to detect the relationship. So 1 minus beta is that you are succeeding to recognize the effect, or you are able to detect the effect. So always you should try to see that the statistical test, the devices, the instrument whatever you are using, they must have a good power. That means they should not they should always able to detect the effect or relationship whenever it is occurring. So it should not fail to detect that actual effect or actual relationship. So what is power? The power is 1 minus beta, which you can always understand. Beta is means you fail to detect the effect. So power is you always succeed in seeing the defect, seeing the effect, or seeing the relationship. A test with high power can detect real effects better. So if the power is high, that means how it can be high? If beta will be very low, if beta will be 0.04, 0.03, then power will be high. So higher power, lower type 2 error. So you should try to increase the power of a test, so that it should be able to detect the effect or relationship. So probability of correctly rejecting a false null hypothesis. What is power of the test? Power of a statistical test is probability of correctly rejecting a false null hypothesis. So if suppose beta is 0.05, then it is 0.95, that means the probability will be 95%. If beta is 0.04 or 4%, then the probability will be 96. Similarly, the probability can become 99 also. So there is always requirement that in the experiment the power should be more, so that you can see the effect of the experiment. Always you can increase the sample to improve the sample size. Increasing the sample size is always important, so that you can detect each and every type of effect whenever it is happening. So when the sample size is large, the power will be high, because we can always see the effect. Effect size larger, difference easier to detect. So if the difference will be high, then also we will be able to detect the effect. Suppose the difference in the achievement of experimental group and the achievement of control group, that difference is very high, then also we will be able to detect the if or you will be able to see the effect. Now if you increase alpha, so it may be there. If you increase alpha, then power will of course increase, but you may be at a position of committing type 1 error. Suppose you increase alpha, suppose your alpha was previously your alpha was 5%, now you have made it 10%. So you have increased the alpha to 10%. That means now if you will be in the position of rejecting the null hypothesis with taking 10% chances. I think you can understand. If you increase alpha, suppose the general alpha is at 0.05 or 5%. Now if you increase alpha, that means you make it 10%. So now you are taking 10% chance to reject the null hypothesis. Now it is always there that okay, null hypothesis should be rejected when it is false, and that is power of test. But the chances of committing type 1 error also increases, because maybe many a times there is not difference in reality and you are detecting it because you have increased alpha, you are taking more chance. So you have to be very much sure that if you are increasing alpha, then you are not committing type 1 error. Of course it is increasing the power, but you should be seeing that there is no negative effect. So you cannot say that you can increase alpha to 40%, 30%, and in any position you just try to reject the null hypothesis. Maybe or many a times it may be that null hypothesis is actually true and you have rejected, so that you have to take care. So what I was talking about, that of course if you reduce alpha, you have seen that you can always increase alpha, so you will be in better position to reject the null hypothesis, but you may commit alpha errors or type 1 error. But if you lower alpha, it reduces type 1 error but increases type 2 error. So that also case is there, that if you reduce alpha, that means your alpha is suppose 0.05, now you make it 0.03 or 0.02, then you are able to control type 1 error. That means you will not falsely reject null hypothesis, but again the chances of committing type 2 error increases. That means maybe there is difference and you fail to detect, because you are taking less chance by reducing alpha. So in a medical test, reducing make the test stricter, decreasing false positive but increasing false negative. No, suppose in a medical test you try to detect, suppose if sugar is present, or that person is having blood pressure, or he is having thyroid problem. So if you reduce alpha, of course in medical test, this type of test, you should reduce alpha, so that you should not go for taking or making a false positive statement. That means you are saying that the person is having sugar, or the person is diabetic, or the person is having blood pressure. But it should not be also like that a person is having a sugar problem or person is having a blood pressure problem and you fail to detect it. So that's why you just try to see here the power of test comes into play. That's why whenever you are going for testing of a particular problem, you try to go to a center who is very much recognized. The power of test is best understand you can best understand power of test by this particular case. That means you prefer to go to a branded company to conduct a blood test, so that whenever the problem will be there, it should be detected. So you should not or you should not also get a false positive, or you should not also get a false negative. So in that way also you can understand. Similarly, lowering alpha reduces type 1 error but increases type 2 errors. So I already told you that if you so you can also understand that if you decrease alpha from 0.05 to 0.01, then you are in better position to reduce type 1 error, but you should be careful also that you should not commit type 2 error. So lowering of alpha reduces type 1 error but increases type 2 errors, which I already told you. So how you can reduce type 2 errors? That means you should not be in a position to not identify the differences or not identify the effect. So you can always increase sample size, or you can go for improved measuring tools, which I already told you that if you go for a blood test, then you should go for a good vendor, a good diagnostic center, so that your reports will be valid one and you will not commit type 2 error. So you can also understand this particular concept of alpha and beta, or type 1 error and type 2 error. Suppose you lower alpha to 0.01, the test become more conservative. That means you can say that the achievement is very low and that particular method is not working. Suppose you conducted a experimental study and you have given the experimental treatment like activity based method, and then you go for a test. You conducted an achievement test and it is quite hard, or you can say that not quite hard means it is quite hard. That may be the case also, but whenever you are taking the decision, you have try to reduce the level of significance, that you are trying to take only 1% chance of falsely rejecting null hypothesis. So of course you want some higher value of statistical test, so that you can say that that particular method is working. So test become very conservative and it reduces type 1 error but increases type 2 error. That means you can say that okay, that our method is not working, because it may be working, but because you have gone for a very conservative test, you have applied alpha at 0.01, you are not able to identify the effect. And if you increase the alpha, you make alpha 0.10 or take 10% chance, so it will increase alpha error or type 1 error but reduces type 2 error. That means whenever some chances, some effect will be observed because of activities based method, you will be able to detect that one. So in medical testing, type 1 error, diagnosing a healthy person with a disease, false positive, that is also a bad position. And if you fail to diagnose a sick people, that is false negative, that is also dangerous. And I told you that that's why you go to a good diagnostic centers and you increase power of test, that is 1 minus beta, so that if the problem is there, it will be detected. You should not be falsely detected, you should not be failed to get detected if you are actually ill. So balance needed based on disease severity and treatment consequences. Always if the disease is quite severe, you should be going to a good diagnostic center or increase the power of test, so that the problem should be identified at the earliest possible time. Falsely failing to students, in the if you take example from the field of education, falsely failing a student who actually understand the material. So type 1 error, you say that the material is ineffective or it is same as the old material. but actually if it is working, then and you take a decision that it is not working, then it is type 1 error. And second one, so type 2 error is passing a student who lacks understanding. So your in reality there is no understanding, and you are trying to see that okay, the understanding is there, and you pass a particular student. So that is also a wrong interpretation. So now try to understand a problem from the field of education. Or suppose your null hypothesis is that the a person is passing. Every person can pass that test. That is, or you can say that understanding does not matter. So now take an example from education field. So you can see that this is type 1 error and type 2 error. Example is given. It says that suppose the case is that a particular person reads a material, understand the material, and then he passes. That should be the null hypothesis, that a person read and pass this examination. But if you in reality, that is the fact, that if a person will read a particular material, understand it, then they will pass. But if you fail that particular student, you are saying that no, that person is failing. By reading that material, he is failing. So that is type 1 error, because if he understand, he should pass. In reality also he understand the things and he passes. But you by maybe your what you can say, your test is very poorly constructed, your test is very poorly conducted, or the chance that you have taken, that is also quite high. You are taking 10% chance or 15% chance. So you are failing a student who actually understand the things. So that is type 1 error. Now the second case also may be there, a particular person who actually read the material and he is not understanding the things. So he should actually fail, but you passed him. You are taking a decision by passing him. That means maybe your test, whatever you have conducted, it is quite easier one, or you have what you can say, you have reduced it beta level, and that's why you are committing type 2 error. Okay, so the fact may be there that he is reading the material but he is not understanding, and maybe because you have make it test which is quite easier and not based upon that particular reading material, maybe that particular person is passing, but actually he should fail because he is not reading and not understanding the things, but you are passing it. So you got for a thing which is in reality which should not be happening. So it is the case of type 2 error. So other cases, other example in case of hiring can be whenever you are hiring a person, rejecting a good candidate. If you fail to recognize that particular person, a good candidate is there, and you fail to recognize him and reject him, then it is type 1 error. And if you are successfully appointing a person who is not qualified, then it is type 2 error. So if the person is unqualified, he is not good, and you are hiring it, then it is a type 2 error. So how to minimize the errors? Always you have to increase the sample size, choose a optimal significance level of alpha based on the context. So if it is a medical test, you have to reduce your alpha. If it is a problem from social sciences, in general life, you can always keep your alphas with something higher level, so that type 2 error will be less. So optimum level is there. You cannot reduce it and make it to up to 0, or you cannot go on increasing it and make it 40%, 50%. So based upon the context, the situation, you should decide upon your alpha. Improve measurement tool, whatever measurement tool, devices, process that you are using, that has to be very much good one, so that the precision should be there and you should not miss the things. So what we have read in this particular video, what you understand in this particular video. So type 1 error is false positive, rejecting a true null hypothesis. True null hypothesis is there, and you reject it. The null hypothesis is there is no difference, there is no significance, there is no correlation, but you reject it. In reality it was correct, but you reject it, so it is false positive. And type 2 error is false negative. Maybe there is effect, there is a relationship, but your test is not having that power to detect that particular effect or that particular correlation. So that is type 2 error. Lowering alpha reduces type 1 error but increases type 2 error. Power of test help to detect real effects more accurately. So you should always try to see whatever test you are doing, water measurement devices you are using, they have got a good power. So whenever effect or relationship will be there, it can be easily detected. So always you can try to compare type 1 error and type 2 error. Definition, it is false positive, type 1 error is false positive, and type 2 error is false negative. Symbol, it is called as alpha, and second one is called as beta. Effect of lowering alpha, type 1 error decreases but type 2 error increases. Effect of increasing sample size, there is no effect on type 1 error, but there is always decrease in type 2 error. So always you try to, because in the other one case there is no effect, but because it decreases type 2 error, you should always try to increase the sample size. So that's why every time you try to have a good sample, so that whenever some effect or relationship will be there, you will be able to identify that. So before ending this particular video, let me try to ask you that which type of error is more dangerous, type 1 error or type 2 error. So many a times the question comes that which error is more dangerous. So try to understand that from that classical court case example. We have got this saying that maybe we are falsely acquitting many criminals, but you should not in anyhow you should not convict innocent person. जैसा कि हिंदी में भी बोला जाता है कि 1000 गुनाहगार छूट जाएं लेकिन किसी बेगुनाह को सज़ा नहीं होनी चाहिए. सो किसी बेगुनाह को अगर आप सज़ा दे देते हैं, इफ़ ए इनोसेंट पर्सन इज़ convicted, then it is a big mistake. So we can say that type 1 error is always more dangerous. So rejecting a true null hypothesis, you can always understand. You are saying that a particular medicine is working, you are saying that particular person is having a diabetes or something. So in this way, if you take a decision and that is having certain error, then it is quite dangerous. So you cannot say you cannot prescribe a medicine based on higher level of alpha. That means you have taken a decision based on increasing the alpha level or taking higher level of risk in taking the decision that that particular drug is working. So you should try to see that type 1 error is more dangerous than type 2 error. Now at the end part, we should try to see that this particular questions, which error occurs when a true null hypothesis is rejected, type 1 error, type 2 error, alpha error, beta error. So in terms of error, if we will talk about, of course alpha error and beta error is also referred as type 1 and type 2 error, but it is actually the probability level. So when a true null hypothesis is rejected, then it is type 1 error. If we increase alpha, what happens to type 1 error? If we increase alpha, then it will also increase the type 1 error, because if we increase alpha, that means if you will make it 10% or 20%, then you will be decreasing type 2 error, but it will increase type 1 error, because you will reject null hypothesis which may be true. Now the third question is, which of the following increases the power of test? Of course, increasing the sample size is the answer of this one. A study concludes a new curriculum improves grades, but in the reality it does not. Then what type of error it is? It is type 1 error, because it is not working, but you are saying that it is working. So it is type 1 error. Alpha is given, beta is given, then what is power of test? 1 minus beta, that is 0.80. So C is the answer. In a courtroom, acquitting a guilty person is an example of which error? So a guilty person is there, and if you acquit him, if you make him free, then it's type 2 error. So you can compare the answer with these particular things. So first one is type 1 error, second one increases, so sample size is the answer of the third one, then type 1 error, then 0.80, and last one is type 2 error. So thank you. I hope you have understood type 1 and type 2 error, and what is its relation with alpha and beta, and what is power of test, what is the effect of decreasing alpha and beta, and what is the effect created by increasing alpha and beta, when and which alpha you have to choose to reduce type 1 error and type 2 error depends upon many factors and context. So that you have to consider before taking the decision. So I hope you have liked this particular video, so press the like button and also subscribe to this channel. Thank you.